We all hate the flu. It makes us miserable for a couple of weeks, but then we move on, so it's no big deal, right? Wrong. As shown in frame 1, the flu kills over 80,000 people each year in the Western Hemisphere alone. And its highest demographic are those who are already prioritized to get a flu shot. But that's not even the scary part. Frame 2 shows that a serious flu pandemic is a matter of when, not if. Some strains already have 3 of only 5 mutations that the flu needs to become highly contagious, highly fatal, and transferable between species. All the ingredients it needs to become a devastating pandemic, just like the Black Plague, which killed over 100 million people. And even worse, the flu vaccine that we get every year does absolutely nothing to protect us against this kind of pandemic, which means that everyone in this room and all of your families are at risk. And with all of our current anti-flu drugs showing more and more resistance within the flu, we need a new type of drug, one that the flu can't fight back against, one that is resistant to the flu's drug resistance. And that's where I come in. I'm building on the backbone of amantadine, shown here in frame 3, which is an obsolete drug from the 90s. But what it did was plug this channel in frame 4 like a ball in a hole. You shut down that channel and the flu can't reproduce. Do that, and it's the same thing as killing it. The infection's over, lives are saved, and you're welcome. So in frame 5, we have amantadine again here at the bottom of the structure. But what it has now that it didn't before is this copper atom in orange here at the top. What that does is stick to a site deep inside that channel. If you bind that site, it shuts the whole channel down. And even better, if the flu tries to mutate to get rid of that site, it shuts itself down. So that's a win-win situation for us. And that gives this drug the resistance that we need. So why haven't we seen this type of drug before? Well, it's difficult to design. It can't be too big or it won't fit in the channel. But it needs these arms that hold onto copper tightly or it becomes toxic. But it can't crowd the copper or we're blocking it from binding that target site. So this is our winning drug so far. And frame 6 is just one of the tests that we run to see if our drugs work. As the line goes up, the channel's getting blocked, so this does work. But what does that mean for you? Well, we're sending this drug into animal testing to try to get it to you, and testing some other new designs to see what works best. But hopefully what we're looking at here is the promise of a real defense when the flu pandemic hits. Thank you.